Welcome, ladies and gentlemen, to the second session of elimination methods dealing with systems of equations using the elimination method. Well, as you see, we're given these two systems of equations. We're given this system of equations here. And taking a close look, we can definitely see that they are going to have different slopes. That's going to become -3/2. That's going to become -5/3. So yes, they do have different slopes based on the method that I gave you during the previous first three problems. So now we know they have different slopes. Therefore, we know that these lines are going to intersect at a common point. They're going to share a common x and y value. So what we need to do now is we need to decide, here goes the question. Here it comes. What variable, I'm going to personalize it, what variable do what I want to eliminate? There it is. Because I need to get an equation that has only one variable so I can get a value of that and then come back and use one of the other equations, use substitution, put that value back into one of the other equations to find the value of the other coordinate of the point. So, in this case, what variable do you want to eliminate? Harold? Fred? Okay, Tony? All right, what about you? What variable do you want to eliminate? Which one do you want to eliminate? Okay, well, let's see. This time, let's try the x's. Let's eliminate the x's. So, let's answer the question. Let's eliminate the x's this time. We don't want the y's to think that we're always picking on them. So, eliminate the x terms. Sounds like X-Men. So, in order to eliminate this, we're going to use a concept called least common multiples. Is that correct? We need to look at the coefficients of these x terms. The coefficient in the first equation is 3. The coefficient of the second equation is 5. So now, my question to you is, what is the least common multiple between 3 and 5? What do I mean by least common multiple? What am I asking you? Fred? What am I asking you? I like that word. I like that name, Fred. Cool. Really? Okay. George, what do you think? And Sandra, do you concur? What about you? Well, they said the least common multiple is the smallest number that any two or more numbers can divide into. So, they said that the smallest number that 3 and 5 can divide into is 15. They also recognize that 3 is a prime number, 5 is a prime number. These two numbers are prime to one another. So when you get two numbers that are prime to one another, the smallest number they can divide into is the product of those two numbers. The product of 3 times 5 is 15. So now I know that the least common multiple between 3 and 5 is 15. How am I doing so far? Now we need one more thing to carry through. Now that we know what the least common multiple is between 3 and 5, we need to do one more check. Are these two terms opposite in sign? Ha-ha! That is the other criteria. The terms we need to eliminate, they must be opposite in sign, aren't they? No, they're not. So, next question. Which equation do you want to make the term negative? Let's do it in the first. So, what times 3 is 15? I know you know. That was just like a trick question. 5. Okay, but I want this to be negative. So that means I need to multiply the entire equation by -5. Let's show that. So now I go -5 times the entire equation of 3x plus 2y, and that is equal to -6. Now, using the distributive property, every term of this equation is going to be multiplied by 5. Are you ready? Very good, let's do that. -5 times 3x, -15x. Very good. -5 times 2y. Very good. -10y. Excellent. Excellent. And over here, Sally, -5 times -6 is +30. Very good. Excellent. So far, we have one of our equations that we changed. And here it is. Let me highlight this in green. Voila! Clean! Like on Searching for Nemo. So now, that's a -15. My next question to you is, what times 5 is 15? I'm sorry. I know you already know, but you know I had to ask the question. You know that, right? Thank you so much. Thank you. I know. Thank you. Thank you. Thank you very much. So, yes, 3 times 5. So now, that tells me I have to multiply the entire second equation by 3. Let me show you that. So I take the 3. Whoa. I take the 3 and I multiply the entire second equation by 3. I get 5x plus 3y is equal to 15. Now, what concept am I going to use to do that? I'm going to use the what? I'm going to use the distributive property. Yes. I'm going to take the 3 and multiply every term in this equation by that 3. I'm going to distribute that 3. Everything in it gets multiplied by 3. Is that right, Sandra? Is that right? Am I correct? Don't just take my word for it. Look at it. Make sure. Don't just always believe me. Check for yourself. Do you agree with that? Very good. So let's go ahead and do that. So now I get 3 times 5. That's what? Yeah, that's 15x. Very good. And 3 times 3y. That gives me, good, 9y. Good, good. All right. And, okay, equals, right, because it is an equation. Yep. 3 times 15, and that gives me, very good, 45. So now that I have this other dependent equation, this is a multiple of the original. Now I have those two. Now that I have those two where the first two terms are the same, they have the same common multiple, but they were opposite in sign. Based on what we did during the last problem, what am I going to do with these two now? What do I do? So I did all this work. So what do I do now with these equations? Do you remember what I did with problem number 1? Why did I do all this work? What was the purpose for doing that? Oh yeah, we wanted to eliminate a variable. So how am I going to go about eliminating the variable? How am I going to do that? Can one of you tell me? Oh, okay. Teddy? Oh, yes, exactly, yeah. We're going to put these two equations together and do what? We're going to combine them, is that correct? Very good. Do you agree? Do you agree with all of them? They agree with you as well. Let's take a look. So let's line these up. So right now I have 15x plus the 9y equals 45. Good. And over here, I have negative